Hello, we are going to be talking about radical reactions. These reactions happen through homolytic cleavage. Say that we have a bromine molecule like that. Homolytic cleavage means that this bond that has two electrons cleaves the following way. We'll use fishhook arrows, which means you're moving one electron here. So in the bond, one electron will go to this bromine and the other will go to the other on the other side. And you will be creating two bromine radicals. So that's what we call a homolytic cleavage. So in all of the reactions in the radical chapter, the purpose of that essentially is to functionalize alkenes. So that's the main use. And also, we will have polymerization and other reactions, but in principle, we will be creating from alkanes of different types, we're going to be creating alkyl halides or benzyl or aryl, depends on the structure, but essentially we'll be doing that. And by replacing a hydrogen with a halide, we'll be able to do then other reactions, such as substitution, elimination, and so forth. So it's very important reaction. So all of the radical reactions start with, say, an initiation step. And initiation is what gets started. So we're going to have initiation. I'm going to write it above. So something like that if we had a bromination. An initiation step. Then we will have propagation steps. And say here that I have an alkane, and in that propagation step, it's going to say react with that radical. And now here you're going to have the electron movement. This time it's here, homolytic cleavage, so one electron here in, one electron from the bromine is going to create HBr, and you're going to form another radical. So now you have the R radical plus HBr. That's one propagation step, and notice that you are starting here with one radical and you're producing another radical, so this plus that. So, and then to finally have the halogenation, so the halide replacement, the H by the halogen, we will have, and we'll keep the bromination example, this reacting with another molecule of bromine, and then we will have again another homolytic cleavage of the bond here, and this with this is going to form, but first this is cleaving one electron to that side, one the other side, and you're going to be creating now the brominated product in the case of bromination, and another radical. But notice that now you're forming another, and this is capable of doing the same thing, another hydrogen extraction and so forth. So propagation steps lead to more reactions. And then we have termination steps. And in termination, we're going to be having, for instance, we can have steps that actually cancel radicals. If you had two bromine radicals, and let's do all the electrons here. If you make this, for example, you no longer have radicals. Or you can have two molecules like that, the radical coming from the alkane, and this will get in together. That will be a possible termination step. So that's it. It is important to keep in mind then those steps when we are solving problems. But in general, this is it. And we be looking now at species that actually can facilitate this process, such as initiator, and species that actually can terminate this, which are called inhibitors. So we're going to be talking about that in another video.